So this project is about real-time carbon monoxide gas monitoring system developed for ambulance cabin environments. The system uses an ESP32 as its main core and manages DHT22 for temperature and humidity sensor and also MQ7 for carbon monoxide sensor. The data is shown on I2C LCD and LEDs with Blink IoT to integrate for remote smartphone monitoring. So our project is essential when in ambulance cabins, there will be silent carbon monoxide accumulation that comes from the exhaust of the vehicle, from the ambulance, that poses a little risk for the paramedics and especially the patients. This system monitors carbon monoxide level using ppm in real time, providing local alerts via LCD and also LEDs, while transmitting live data through the Blink IoT dashboard that we uses with Wi-Fi to the remote oversight by the hospital or field supervisors. And the DHT22 tracks climate, while on the LEDs, which consists of red, yellow, and blue, provide instant status about the carbon monoxide status in the ambulance. The ESP32 also sync with the Wi-Fi for the Blink to enabling remote smartphone monitoring by authorized users.
Well, this is our literature review for our project, which we use 3 existing projects that we found on the internet to be compared with the project that we are doing. Well, basically, we have chosen every component and every idea that we have created and compared the best data that we got from 3 of these projects that we found online. Well, for the methodology part for our project, the ESP32 microcontroller acts as the central hub for this project, which receives analog data from the MQ7 sensor to detect carbon monoxide value, and also receive digital data from DHT22 sensor to detect the value of temperature and humidity. Well, then the process reading are output locally via the 16x2 LCD I2C display and 3 LED indicator, which is blue for safe, yellow for warning, and also red for danger mode. Well, then live data is also transmitted remotely to the Blink IoT cloud dashboard via the ESP32 built-in Wi-Fi.
So, the system was tested under 3 carbon monoxide exposure conditions. For our first demonstrations, the system was tested indoors under normal conditions, registering 0.66 ppm, 34.1 degrees Celsius and 61.7% humidity. So the blue LED illuminated, confirming a safe environment. In the second demonstration, the sensor was exposed to a real vehicle exhaust where carbon monoxide spiked to 206 ppm, temperature rose to 35.1 degrees Celsius and humidity reached 83.9%, immediately triggering the red LED and danger alert. Prior to that, at 92 ppm, the yellow LED also activated correctly, indicating a warning state. Across all 3 conditions, each alert level, safe, warning, and danger, triggered accurately and in line with the threshold set in our code, with no false reading. For the conclusion, this project successfully developed an ESP32-based carbon monoxide monitoring system for ambulance cabin, integrating DHT22 and MQ7 sensors with Blink IoT for real-time local and remote monitoring. All objectives were achieved with carbon monoxide level classified via a color-coded LED, a 1.1 second response time, and 300 to 600 milliseconds cloud latency at a cost of approximately 78 ringgit. Future work includes push notifications, GPS integrations, and weatherproof and